2 by 10 factorial.
Sorry. So it is 2 by 10 factorial.
Yes.
Right. And that's it. That's it. Problem solved, right? It's the so then Px would be this plus x. So that's certainly not a bad representation, right? If it's a good rep, you would say that this is not a bad. And what better could you ask? Because if you expand this, questions are. This is nice. So this is how we want to do the other question. Lagrange interpolation is there, but you have to see. You need Lagrange interpolation or you don't need it. So more than Lagrange interpolation, the method that we use to build up the polynomial, in that you have to understand also. Obviously, Lagrange interpolation itself will be useful in the exams like in MCQs and so on, even in subjectives. Let's come to the original question. So here we had P of k equal to 1 by k, where k is ranging like this. P of 0 is, I don't know, anything 1. And the degree is less than 10, less than equal to 10.
Here A will just be 0, right?
A will be 0. A is the leading coefficient. So what is A? You mean the leading coefficient?
Yes.
So okay, in what way? So my question is that if let's say that P, if this is x to the 10, so then do you mean that it's a 9-degree polynomial or degree is strictly less than 10? Or is it a 0 polynomial? It's not 0. It's 1 by k.
No, sir, I meant A is what we multiply the other terms to
Yeah.
get pk minus 1 by k.
Right. So, so then yes, no, but that cannot happen, right? Because then P is a 0 polynomial. But P is not 0. P of k is 1 by k. Not possible, right? 0.
When we put P of 0 as 1, then we are getting that only, right?
But how? So what are the Yes.
10 factorial.
Yeah, we are getting something like that. Okay, so let's see. So I mean, let's so someone take me through the method. How do we get to anyone?
So x minus 1 into x minus 2, x minus half.
X minus half.
X into x minus 1.
Wait, okay. And why x? Okay. So
okay, there is no x. Sorry. X minus half all the way
x minus
up
half.
to x.
Okay, x minus half. Oh, you're saying x minus 1, x minus half. Okay. Why? Okay. So then what?
Then a will be.
No. But this is what? Like this is equal. This is just a polynomial. How is it related to our question? Is a polynomial, but how is it related to our question?
Equal to pk minus 1 by k.
P equal to pk minus 1 by
p of x minus.
It's equal to p of x. Oh, so the problem is that can anybody tell problem in this?
It can't be x minus half. It has to be x minus 2 into x minus 3.
Oh, okay. So maybe I'll take that candidate also. You're saying this will be equal to. Even then, I see a problem. Yeah. So first of all, let us see. So let's write both the candidates and then maybe A also. Okay, fine. No. So the problem with this thing is how is it happening? So if I put p equal to half, does the left hand side vanish? No. Right. So certainly this is not true. Okay. Yeah, it's not true. So we forget this. This is not working. Even with this one, there is a problem. Even this is problematic. Why? Can anybody tell? Well, yes, I understand that this at 1 it is vanishing. So you put x minus 1. At 2 it is vanishing. You put x minus 2. But means 2 is a root. Then x minus 2 is a factor. But that only happens for polynomials. This is not a polynomial. Is it a polynomial? No, it's not. It cannot be a polynomial. It's 1 by x. So for these kind of things which are not polynomials, zeros don't correspond to factors. For zeros, suddenly you don't get a factor. Those things only happen for polynomials. Polynomials are special functions. Right? Otherwise, you look at sine x, right? It vanishes at pi, 2 pi, 4 pi. Does it mean that sine x is x minus pi times x minus 4 pi times x minus whatever, right? Is it true? No, that's not true. The sign is not like that. So otherwise, it will be an infinite product. Okay, it turns out that it is like that to some degree, but that's due to some other fact. I mean, those things are there always, but you cannot say that without proof. That does not. So that's wrong. Zero.
xpx minus 1.
Xpx minus 1 you can consider, right? That's the thing. You have to make a polynomial out of the question. Otherwise, you cannot say these. Xpx minus 1, yes, it's a polynomial. Px is a polynomial, x times px is a polynomial. Subtract 1, it's a polynomial. Now we can go forward and try this. And then it's a good old business. This vanishes at 1, 2, and k. That's what's given in the question, right? That's the thing. You have to convert it to a polynomial situation and look at the roots, what gives you the roots, and consider that for correct kind of polynomial, which is, and then you can say, yeah. And then literally there's nothing, right? Again, you just find A by putting what. But by putting 0. But let's see, I mean, is there a problem? Have I said something wrong? Have I said, let's see. So no, I don't think there is a problem. This is coming out good. Right, this is a non-zero number, this is non-zero number. Come out to this. Okay. Right? So it's not a problem. So you will get a polynomial. So what is A? Please tell.
1/10 factorial.
Okay, 1/10 factorial. So are we done? We are not done, right? Because we have to find Px. Right? We have to find Px. So this is okay. But we have to ensure that Px is the polynomial. If this is the x, then it is not 100% clear that this is a polynomial. It might not be. X has to divide the numerator for this to be a polynomial. X has to divide the numerator and then you can factor out the x and then cancel the x, and that will be a polynomial. This, as it's written, is not a polynomial. All right. Firstly, you cannot really take the x down like that, but I mean, taking that down and canceling would give you something will actually matches with the x. But let's say we take it down for a minute, and you have to check that. So does x kill the numerator? So first, I mean, is it clear to everyone that the problem is not done? If you leave it here, you have to explain a little bit. I mean, after some level, it will be clear to you that it is a polynomial. But forever, at right now, it is not clear, right? You can get asked, why is this a polynomial? There is an x in the denominator. Is that point making sense? Right? So explain why this is a polynomial. Because as it is written like this, it is not. But is x a root of the numerator? That you have to show. First thing, is x a root of the numerator? How do you know that? You don't have to think. Just substitute x equal to 0 in the numerator and see if the numerator vanishes. I mean, okay, so if is x a factor of the numerator is what I'm asking, right? That same thing is 0 a root of the numerator, right? I mean, is the numerator equal to x times a polynomial? That's the same thing as asking if 0 is a root of the numerator, right? And so you put x equal to 0 and check if the numerator vanishes, and it does, right? You put x equal to 0 in this, you do get, okay, I hope you check it, some minus 10 factorial by 10 factorial. This is what you should get, and it will be 0. Okay? Or I think something is wrong. Something wrong?
Why minus 10?
Why minus 10, right? Is it is not minus 10, then okay, I wrote minus 10 because then from 0 from 0. Okay, so maybe this was coming out to be minus 1 by 10 factorial. Just check the calculation. Just check. Just check it and see it. Okay. Basically, you have to just check that putting x equal to 0 makes the numerator 0. And for that, I believe there should be a minus there. Check it.
Yeah, it should have been minus.
Right. And then the point is that putting x equal to 0 makes this 0. And so then you know that this is equal to x times some qx. But that qx is not known, is not very easy to find. And so we leave it, it's okay. But we know in our mind, and we know that this numerator is x times qx. And therefore, this final thing is qx. And the px is that qx. What this does is it doesn't help you to find the QX, but it tells you that Px will be a polynomial at the end of it. Okay, but you are not going to be able to write it as a polynomial. You are going to be able to write it like this only. So you write it like this. You use the x in the denominator. So you write it like this, but you know that it's going to be a polynomial. So the answer would be, this is how Px looks like. For the simplicity of the representation, I have to use a 1 by x, but I know it's a polynomial. Maybe it's given in the question in the polynomial, but basically that's not it, right? The fact that it is given in the question that it's a polynomial is not enough. You have to show explicitly that this what you have found is a polynomial. Otherwise, you say no polynomial exists. So you find this Px, you write it in this way, you use x in the denominator, but then you show that, okay, the numerator has x as a factor, so this is a polynomial. But I'm writing it in a non-polynomial way, because when if I write it in a polynomial way, because so easy to write a polynomial, we have to sometimes go to a non-polynomial for an easy representation. That is what is happening. But not a problem. We at least have found an expression for Px which can be used to calculate, let's say, P of 100 in a flash, P of 1000 in a flash. At least, product plus 1 by 1000. Simple. So it's a useful way to write Px. More useful maybe than just saying P of k is 1 by. Okay. We have done something. And we should also know what we have not done and what is not possible. All these sides are there. But for this, you have to, the things that we did earlier, what is a polynomial and so on is. Okay. So I think I'll stop here. Okay. Yeah, let me just stop here. Maybe for homework, and this was also there in Brilliant, but maybe some more questions can come out of it. Let's say that P of n, let's say that P of n is equal to f of n, where fn is the Fibonacci numbers. Okay, for n equal to maybe 1 to 10, okay? And let's say degree is less than equal to 9. Find Px. Next question is there a polynomial such that P of n is equal to Fn for all n? Fn is the Fibonacci sequence. Okay, so Fn is like 1, 1, 2, 3. Fn is F1, F2, and so on. For all n, is there a polynomial so that this happens for all n? That is the question. And well, the next question is maybe find a polynomial. Find, if you have done trigonometry, find a polynomial P such that P of cos theta is equal to cos phi. If you cannot do this for 5, do it for 2, 3 at least. 2, 3, 4. 2 is just an identity, right? P of cos 2 theta is 2 cos square theta minus 1. So P of cos theta is 2 cos square theta minus 1. So Px is 2 square. But yeah, you think and do. Yeah, try these 3 problems. So we have to moving outside interpolation a little. Okay, and that representations we will all we could do today. Okay, so I'm ending it now. Okay, so again, timings are same. You guys know the timing. So yeah, let's keep it.
It will be on Sunday 2 classes or
yes, yeah. So yes, so let me write this. So Sunday 4 p.m. Right? Yeah, 4 p.m. to 5 p.m. IST. This is one class, and here we are doing number theory, focusing on the problems from Olympiads now. No, not doing much theory now, but learning like in a different way. And because we have covered something, and here also we will do the same thing, maybe from next class or next week. This is 9, all are Indian Standard 9. Mess up, then don't tell. This is obviously we are doing polynomials. And then there is another class, but I suppose not everybody is doing that, and it's okay. Those who are not doing it, don't. It's okay. You have enough things on your plate to do that. Spend time on that. And this is 9 p.m. to 10 p.m. This is I upload this on YouTube also. The sequences thing, sequences and recurrence. But okay, don't do it now. Spend more time on what you're learning. That's more important. These three are what we are doing on another college. Okay. That's it. Thank you.
Is there any way to move the 4 p.m. class to like a bit later?
No,
Only on next.
on Sunday, only on next Sunday.
Yeah.
So about others, are others fine with? Mostly, I will not be fine with 5 p.m. to 6 p.m. But if I am, then are others fine with 5 p.m. to 6 p.m. and so on Sunday?
Yes, I'm not wrong.
Okay.
Yes.
How about earlier? 1 to 2 or sorry 12. I don't know if it will be too early for Pragdish. 12 p.m. No, I don't think it's too early. 12 p.m. to 1 p.m. Nagesh, is this okay? Or
Sir, I have a class till 2.
okay. No, so yeah.
Okay, I think it's better. It's better with the 4 itself.
For itself. Okay.
Yeah.
Otherwise, I mean, if otherwise I can do 7:30. I can try to make it 7:30. But do you think 7:30 will be better? Then I will ask.
No, it's fine. I think.
Okay, then.
No, they do continuous class.
Okay. So then we'll do this. Okay, that's it. And this one maybe what I'm doing is, and I also wanted that, and I hope everybody is okay with it. Not just tell me immediately. Want to start this from T45. Is it okay with everyone?
Yes, sir.
Yes.
Okay, Pragdish, you also?
Yeah, it's okay with me.
Nagesh, so because this is for some reason of my own, 345 to 440. Okay, so we'll do this.
Yeah.
So don't forget this. Don't this. Yeah. Okay, or write it down as well if you need. Okay, then that's it. See you. Bye. Good night. Practice the things over the week.